is greater than 1, a vertical stretch takes place. And you have to tell me a vertical stretch by what amount. For this particular equation, we have a vertical stretch by 3, and my graph becomes skinnier or more narrow. The original graph, and this is compared to the original graph. Now, if I had a question, y is equal to 7x squared, but there is a negative in front of the 7, I want this to be very, very clear to you. The negative refers to one type of transformation, okay? Whenever you see the negative, you write reflection in the x-axis. That's one transformation. And then, after you do that, you kind of cover the negative and you determine what your A value is. Your A value is greater than 1, therefore a vertical stretch by 7 has taken place. So many times I have students tell me, oh miss, this is not greater than 1 because it's -7, so it's not a vertical stretch. But that's not the case. Negative refers to the reflection transformation, but it has nothing to do with the value of A, okay? So really highlight that, make a big star to remind you of that, because that can really screw you up on the test if you don't remember that simple rule. Now for, I can do this. Well, we've already seen that if A is going to be, if we have the opposite situation, so give me 1 second here. No, okay, let's just erase this. For my third transformation, it still has to do with my A value. So this time, instead of 3, I'm going to change my A value slightly. So I still have my parent function, but the third transformation is going to refer to what I call a vertical compression. And as we already discussed, a vertical compression happens when our graph becomes wider. Okay. Now, this term, vertical compression, often trips students up because when you think compression, you usually think like this. You compress like this and your graph would become skinnier, right? But when we talk about vertical compression, if I had a big beach ball on the desk and I took a vertical force, my hand, and just like squashed the ball, what would happen to the beach ball? Yeah, it would expand and it would get wider. So whenever you think about vertical compression, think about that beach ball and a vertical force coming, exerting a vertical force on the beach ball, so the ball would expand and your graph also expands and becomes wider. Now, you have to be careful with vertical compression and what your A value refers to. So vertical compression is going to be in between the values of 0 and 1. Remember on schedule days we talked about how this means in between the values of 0 and 1. So it can be anything between 0 and 1. What do we call numbers that are in between 0 and 1? Decimals, that's one thing. What's another term for numbers that are in between 0 and 1? You hate them. Fractions. So whenever you see fractions, you got it right away when I said you hate them. Fractions or decimals. But you have to have decimals less than 1. They can't be decimals greater than 1, and that's the way I always try to trick students on the test. If I say 1.5, that wouldn't be a vertical compression because it's greater than 1. It's only decimals less than 1. So for example, y is equal to 1 over 4x squared. This would be a vertical compression by 1 over 4, 1/4. Vertical compression by 1/4. So far on this is my vertex form of the quadratic equation. I've dealt with the first transformation, second transformation, and third transformation. You have to be able to memorize what each transformation, the criteria for each transformation, and that has to stick into your brain all the way up till grade 12. So here I have a quadratic equation. Let's make that 1. Let's make this 0. And let's make this, we'll make this 0 as well. So we've already spoken about if this equation, if your A value gets bigger, your equation gets skinnier and skinnier and skinnier. However, and we've also spoken about reflections and your graph getting wide. But now we have to talk about having your equation move either left or have your equation moving to the right. So left and right, that's what we're really going to focus on. And this type of transformation is the most difficult because you're going to have to think in terms of opposites, okay? So in big letters, write the word opposite next to this next transformation. And I'm breaking up my fourth transformation into 2 parts. So this is going to be 4a, and it's called the horizontal shift. Okay, so horizontal shift, whenever you do horizontal shift, we have y is equal to, now x squared is my parent function, the original function, but with horizontal shifts, they will only take place when you have terms inside the brackets, okay? So you're going to have a set of brackets, and the reason I said opposites, if you have a negative value, so negative h for example, this is going to be a horizontal shift to the right. Horizontal shift to the right. And then if you have a situation with y is equal to x, and you have a positive value inside, positive value inside the brackets. So usually when you think positive, you would think right. But here, this would be a horizontal shift to the left. And I'm going to tell you why that's the case. So you'll remember in Unit 8, when you were solving inside the brackets, so if you had like x minus 3 and x minus 1, well, let's just deal with one of the roots, x minus 3. And if you set that equal to 0, so when we see a negative 3 inside the bracket, but we're setting the equation equal to 0, when that negative 3 moves to the other side, so if we're trying to solve for the value of x, we have to move that negative 3 to the opposite side, so the actual value of x is positive 3. That's why when you see a negative inside the bracket, the actual value of that is a positive number. That's why we move right. The actual value of a positive number you see in the brackets is a negative value, and that's why that moves to the left. So always, always think in terms of opposites. So I'm going to give you an example.